Today we're going to continue with our discussion on permutation and combination. In permutation, it was discussed exhaustively, and of course we capture almost every aspect of it to enable us to solve problems in permutation. Today specifically we shall be looking at combination, which is also called selection. A combination is an arrangement in which order is not taken into consideration. What we are saying is that for AB and BA is one selection. In permutation, AB and BA are two selections or two arrangements. But in combination, AB and BA is one selection. Now, the number of combination or selection of n objects taking R at a time is written n combination R. That is n combination in full and R. The C there represents the combination. We have some properties of combination. Number one, n combination R is equal to n factorial all over R factorial into n minus R factorial. This will be equal to n permutation R all over R factorial. You would recall that n factorial over n minus R factorial is n permutation R. And this arrow at the denominator is this arrow here. Hence we are saying this value is equal to n permutation R all over R factorial. So n combination R is equal to n permutation R all over R factorial. The second one is n combination 0 is equal to n factorial all over 0 factorial n minus 0 factorial simplified to n factorial over n factorial, because 0 factorial is 1 and then the answer is equal to 1. Then n combination n in this case is equal to n factorial over n factorial, because this means 0 factorial. Okay, let's take it this way: n factorial all over n factorial, then n minus n factorial. N minus n will be 0 and then n factorial will remain, which will be equal to 1. The last one, R factorial into n combination R, will eventually be expressed like this: R factorial will carry R factorial, leaving you with npr, because n factorial over n minus R factorial is n permutation R. Take note of this relationship, as we shall be using them in solving problems in combination and also in permutation. Example number 1. Evaluate 5 permutation 4 plus 7 combination 4. Our solution, we have here 5 permutation 4 is equal to 5 factorial all over 5 minus 4 factorial. This is equal to 5 factorial all over 1 factorial, and that will be equal to 5 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. That will be equal to 120. Then you take your 7 combination 4 is 7 factorial all over 4 factorial, 7 minus 4 factorial, and this eventually will give you 7 factorial all over 4 factorial, and that is 3 factorial. So the numerator will be 7 times 6 times 5 times 4 factorial all over 4 factorial, and then of course times 3 and then times 2. 4 factorial will cancel, 3 times 2 will cancel that, you are left with 7 times 5, and that is equal to 35. So the sum, therefore, we have 5 permutation 4 plus 7 combination 4 is equal to 120 plus 35, and the result is equal to 155. Example number 2. In how many ways can 6 people be paired? Solution: here a pair is equal to 2. So in how many ways can 6 people be paired? So the number of ways that this can be done is 6 combination 2. And so that becomes 6 factorial over 2 factorial, and 6 minus 2 is 4 factorial. Giving you 6 times 5 all over 2, and that is equal to 15. So 6 people can be paired in 15 different ways. 5 people can be selected or arranged, taking 2 at a time in 15 different ways. Example number 3. If 6 combination R all over 6 permutation R is equal to 1 over 6, find the value of R. Solution. We have 6 combination R all over 6 permutation R equal to 1 over 6. You will recall that 6 combination R is 6 permutation R all over R factorial times your 6 permutation R, and everything is equal to 1 over 6. Now 6 permutation R will cancel 6 permutation R. You are left with 1 all over R factorial, which is equal to 1 all over 6. Cross multiply, R factorial is equal to 6. And you will recall that 6 is the same thing as 3 factorial. So factorial, we cancel factorial, therefore our R is equal to 3. So the value of R is equal to 3. Take note of how I proceeded from 6 to 3 factorial. Example number 4. The expression n combination R is equivalent to A. R combination n minus R, B. N combination R plus N, C. N combination n minus R, D. R combination n plus R. Our solution, you will recall that your n combination R is equal to n factorial all over R factorial into n minus R factorial. From the options given to us, which of them will be equal to this? So let's try n combination n minus R will be equal to n factorial all over n minus R factorial into our n factorial n minus R and all in factorial. Okay, let's simplify this. N factorial all over n minus R factorial, and then this becomes n minus n plus R, or in factorial. Simplify to become n factorial all over n minus R factorial, and this is equal to R factorial. You now realize from what we have, therefore, n combination R is equal to n combination n minus R. And that is the correct option. And option C is the correct one. Option C. Example 5. In how many ways can a committee of 2 boys and 1 girl be selected from a group of 5 boys and 3 girls? Solution. Here we have the number of ways of doing this. We select 2 from 5 boys, and then we select 1 from 3 girls to form a committee. So that's how we're multiplying. And so at the end we have 5 factorial over 2 factorial times 3 factorial, and then 3 factorial all over 1 factorial times 2 factorial. This will give you 5 times 4 all over 2. This will give you 3.2, that is times also over 2. This will go, this will cancel this 2. Leaving with 5 times 2 times 3, and that is 10, and that is equal to 30 ways. So we have 30 ways of selecting a committee made up of 2 boys and 1 girl from the group.